We present R-DMesh, a feed-forward framework for video-guided 3D animation. Given an arbitrary static mesh and a corresponding reference video, R-DMesh generates high-quality, motion-aligned 4D mesh sequences. Given a static mesh, and a reference video describing the motion, the task targets to generate motion-aligned 3D animation sequence. In practical scenarios, however, the initial pose of a user-provided mesh rarely matches the starting pose of the reference video, which results in animation failure. We aim to rectify the source mesh's pose to align with the starting frame of the video to generate high-fidelity 3D animation. We propose R-DMesh VAE, a VAE tailored for dynamic mesh sequence with initial jump. Given a conditional mesh and a consecutive mesh sequence with the same identity, we first decompose the input into 4 components: faces, initial vertices, jump offset and trajectories, where the jump offset models the pose change. Subsequently, different positional encoding mechanisms are performed to project the features to high-dimension space. To incorporate topological information, the faces are converted to adjacency matrix and perform as an attention mask to aggregate local geometry information into vertex features. At the core of our encoder, we introduce triflow attention. This module encodes local rigidity by employing vertex features as queries and keys to calculate attention maps that align the 3 modalities. In the decoder, several triflow attention layers strengthen the mutual information of compressed tokens, followed by a cross-triflow attention layer to reconstruct the jump offset and relative trajectories. Finally, the jump offset and relative trajectories are added to the conditional mesh to obtain the reconstructed consecutive mesh sequence. To generate the dynamics, we propose R-DMesh RF model, which model the jump and trajectory distributions. We utilize a video diffusion model, VDM, as video feature extractor for its rich spatiotemporal priors and compressed semantic latent space. Our R-DMesh RF model adopts the DT-style architecture. The video condition is derived from the output of an intermediate block within the VDM's diffusion model. To validate our method's capability in initial pose correction and motion generation accuracy, we first conduct evaluations on a test set with 4D ground truth. In the test set, the pose of the reference video misaligns with the input mesh. R-DMesh rectifies the initial pose and generates high-fidelity 3D animations. Our method generalizes well under common objects, including humanoid, cartoon characters, animals, and so on. We compare R-DMesh with 4 state-of-the-art methods, visualizing the results through rendered sequences. As demonstrated, our method outperforms the baselines. Crucially, it effectively resolves the initial pose misalignment issue, producing 4D outputs that are precisely aligned with the reference video motion. Combining with the sophisticated 3D generator, R-DMesh enables holistic 4D generation. Given an in-the-wild, or generated, video, we first segment the foreground using SAM3. Then, we extract its first frame and feed it to Hunyuan 3D to generate the corresponding 3D mesh. Finally, utilizing the proposed R-DMesh, a motion-aligned, high-fidelity 4D mesh is generated. The whole process are visualized as follows. Thanks to our successful jump offset distribution modeling, R-DMesh is capable of retargeting poses given reference images. Both in the wild and generated reference images are supported. Even trained with only paired video 4D data, our method generalizes well to facilitate motion retargeting application. Our method is quite robust to support manually created 3D assets or generated 3D assets. For reference video, R-DMesh performs well under rendered videos. Generated videos are also supported. Moreover, R-DMesh generalizes well to in-the-wild scenarios. Thanks for watching.